Imagine this. Our planet is wrapped in an invisible magnetic shield, quietly protecting us from dangerous radiation coming from the sun. Most of the time, it works perfectly. But there's one strange region where this shield is weaker than usual. Scientists call it the South Atlantic Anomaly. Here's the surprising part. If you're standing on Earth, you won't notice anything unusual. But up in space, satellites passing through this region can suddenly glitch, reset, or even shut down for safety. And recently, this weak zone hasn't just stayed the same, it's been shifting, stretching, and in some cases even appearing to split into two parts. So what's really going on? To understand that, we have to go deep beneath our feet, far below the surface of the Earth. Thousands of kilometers down, there's a massive ocean of molten metal, mainly iron and nickel, constantly moving and churning at extreme temperatures. This movement generates electric currents, and those currents create the magnetic field that surrounds our planet. But this magnetic field isn't perfectly smooth or stable. It's uneven, constantly changing, and slightly tilted. In certain regions, especially beneath parts of Africa, the flow of molten metal creates unusual magnetic behavior. Some magnetic lines even bend in unexpected ways, weakening the shield above them. Right above one of these weak zones sits the South Atlantic Anomaly. And the interesting part is, we can actually watch it change over time. Thanks to satellites orbiting Earth and mapping its magnetic field in detail, scientists have observed that this anomaly has been expanding over the past decade and becoming weaker. Now, even though we're safe on the ground, satellites in low Earth orbit face a different reality. In this region, high-energy particles from space dip closer to Earth than usual, so when a satellite passes through, it's like driving through a storm of charged particles. Even a tiny burst can flip bits in a computer system, confuse sensors, or force a satellite to reboot. To avoid damage, many spacecraft automatically switch into a protective mode when crossing this zone. Even some of the most advanced space instruments take precautions. For example, the Hubble Space Telescope temporarily pauses sensitive observations whenever it enters this region, just to avoid unnecessary risk. And there have been real consequences. In 2016, a highly advanced Japanese space telescope called Hitomi Satellite suffered a series of failures shortly after launch. While passing through this region, a chain of errors caused it to spin uncontrollably and ultimately break apart, ending the mission far earlier than expected. So why is this anomaly growing or even splitting? Think of it like this. Deep inside Earth, the flow of molten metal behaves like moving magnets. When these flows shift, they change the strength and shape of the magnetic field above. If one weak region expands, the weak spot at the surface expands too. And if multiple weak zones form close together, that single area can appear to split into separate parts. So this shows us something important. The magnetic field is not fixed, it's dynamic, constantly evolving. That leads to a bigger question. Could this be a sign of something much larger, like a magnetic pole reversal? Earth's magnetic poles have flipped many times in the distant past. North becomes south and south becomes north, but not suddenly. It's a slow, complex process where the magnetic field weakens, becomes messy, and reorganizes over time. There's even geological evidence of this. When volcanic rocks cool, tiny magnetic particles inside them align with Earth's magnetic field at that moment. Millions of years later, scientists can study those rocks and see records of past magnetic changes. One example is the Lachamps event, when Earth's magnetic field weakened significantly and partially flipped before returning to normal. Now, the South Atlantic Anomaly doesn't mean a full reversal is about to happen, but it does show that the magnetic field can become uneven and unstable when conditions deep inside Earth change. And while all this is happening, there's another factor to consider: space weather. The sun occasionally releases massive bursts of energy known as coronal mass ejections. These travel through space at incredible speeds and, if directed at Earth, can disturb our magnetic field. This can disrupt radio signals, interfere with GPS, affect satellites, and in extreme cases, even impact power grids. A well-known example happened during the March 1989 geomagnetic storm, when a powerful solar storm caused a major blackout in Canada, leaving millions without electricity for hours. More recently, in May 2024 geomagnetic storm, strong solar activity led to signal disruptions and stunning auroras visible much farther south than usual. The sun operates on an activity cycle of about 11 years, and during its peak phases, these kinds of events become more frequent. Right now, we're in a relatively active period. So while the South Atlantic anomaly is just one region, it's part of a much bigger and more dynamic system involving Earth's core, its magnetic field, and the sun itself. And the real reason all of this matters today is simple. Our modern world depends heavily on satellites, communication systems, and power infrastructure. Even small disturbances in space can have real effects here on Earth. So the next time you look up at the sky, remember, there's an invisible shield protecting you. It's constantly shifting, constantly changing, and scientists are still uncovering its secrets.